Merry Christmas, Happy Holidays, everybody. Welcome back to another lesson. So, today we are going to get into fractions. The long awaited day has finally arrived. So, what are fractions? Well, let's start with some examples. I'm sure most, if not all of you, have seen this before. You have stuff such as 1/2, 1/3, 1/4, 2/3, 3/8, etc. Maybe 1/100th, 1596, so on. Those are all examples of fractions. They are not whole numbers, they are parts of a whole number. So, let's start here. We'll pick any fraction. Let's start with 1/2, because that's probably the most famous fraction, is 1/2. So, in the top part here, you have what's called the numerator. That is the numerator. In the bottom part here, you have what's called the denominator. So, if you want to remember which part is called which, well, denominator, think of it, D, down. It's on the down side, D, down, denominator. So then the numerator's up top. So you'll hear me refer to it as the numerator and denominator quite a bit. Well, actually, no, let's go back to 1/2 here. I mean, I could do it with any fraction, but we'll stick with this one for now. So, what does the numerator and denominator represent? Let's actually start with the denominator. The denominator tells you how many pieces the whole is split into. The whole is split into two separate pieces. And then the numerator is just one piece of that. It's one piece of the whole that's being affected by something, or just represents one piece of the whole. So if I have 1/3, that whole is split into three pieces. The denominator, the whole thing is split into three pieces. I'm talking about one piece out of three if I'm talking about one in the numerator. If I were to do 2/3, then I'd be talking about two pieces out of three are being affected, or representing 2 out of 3 pieces of the whole. But it's not the whole. So, let's see here. I'm going to start, and we're going to form fractions based on we're going to draw some squares here. I'm going to show you how you form fractions. I know they're probably not perfect squares, but let's just argue they're squares. How many squares do I have total? I have 4 squares. So my 4 is going to go in the denominator. That's how many pieces the whole set of squares is split into. I have one set of squares, one set of 4 squares, so the 4 is in the denominator. Now let's say I decide I'm going to shade some of them in here. If I shade one of them in, how many's been affected? How many pieces are shaded? 1/4. So the fraction representation of that would be 1/4. If I shade another in, that's going to be 2/4. So I think you get the idea with where we're going with this. Let's see, let me try to free draw a circle. I don't feel like breaking out the compass right now. Not too bad if I may say so myself. Okay. Let's pretend we have a pizza. A pizza is typically cut in from 6 to 8 pieces depending upon where you get it from. I know it's not the most even, but let's pretend it's a pizza. I'll even draw some pepperonis on it, because why not? Have a good pizza with some pepperoni on it here. Okay. Give me a minute here. I will draw these pepperonis. I'll make us a good pizza. I want to really illustrate a point here. It's going to come in handy. That's why I'm taking the time to draw the pepperonis. That's all these are. Yeah, I'm not quite an artist, in case you haven't figured it out yet, so I apologize for the artwork. That's probably more pepperoni than you normally get on a pizza, I'm sure I'm drawing. Almost done. Draw one more. Alright, I got here a pepperoni pizza split into 8 different pieces. It's split into 1, 2, 3, 4, 5, 6, 7, 8 pieces. So in order to represent the fraction for how many pieces, you're going to start with the denominator of 8, because it's one pizza split into 8 pieces. That's your denominator. Let's say I just shade all that in because I ate one piece of pizza. I decided I ate a piece of pizza. How many pieces of the pizza have I eaten? I've eaten 1/8 of the piece of pizza. Then if I decide I'm going to eat another piece of pizza, well, then I would change it 2/8. And I know some of you out there watching are going to say, that's not in simplest form. You're right, it's not. But that's the next lesson. I will teach how to simplify fractions. Today I just want people to get fractions, what they are. Let's say, heck, I'll eat another piece of pizza. I'll eat from this side. So now I have eaten 3/8 of the piece of pizza. So again, I split into 8 whole pieces. I've taken 3 pieces of the pizza. That's 3/8 of the pizza I've eaten. And then if you wanted to ask how many pieces have not been eaten, let's count. Well, we know there's a total of 8 pieces. How many have not been eaten? 1, 2, 3, 4, 5. 5/8 of the pizza has not been eaten. So you can use fractions for all kinds of things. Let's see, let's do one more example with triangles. I'll do triangles this time. 4, 5, 6. Okay. And then I decide, well, I'll shade in 1, 2, 3, 4. That triangle's bugging me. Let's draw it a little bit better. Can't have a rounded corner on a triangle. That kind of bugs me a bit. Oh, let's shade the 5th triangle. Let's shade a 5th triangle. Alright. So how many triangles do you see here altogether? You see 6. We want to know how many of them are shaded. How many triangles are shaded? Well, we count up how many whole triangles there are. There are 6 triangles. How many are shaded? Well, we count 5 of them shaded. So your fraction for that is 5/6. Now, if we wanted to know how many are not shaded, well, we count 1 that's not. That'd be 1/6. So out of the whole set of 6 triangles, 1 of them is not shaded. Okay. We can also do fractions with a list of names, or with a list. So I'm going to make up some names here. Well, they're going to be real people. Let's see. We have Barack Obama, Avril Lavigne, who else? George Bush. Let's do George W. Bush because there were 2 Bushes. We have Bill Clinton. We have Beyonce, and then we have, let's come up with one more here. Carrie Underwood, why not? Okay, so you can do fractions with a list. We have 1, 2, 3, 4, 5, 6 names. We want to know how many of these names are U.S. presidents. We have a list of 6 names. We have some that are U.S. presidents and some that are senators. How many of them were U.S. presidents? Well, we got Barack Obama, George W. Bush, and Bill Clinton. So out of 6 names, a total of 6, 3 of them are U.S. presidents. So it's one set split into 6 names, 6 pieces. We have 3 of them being U.S. presidents. Also, what if we wanted to find out how many of them were senators? Well, again, it's a list with 6 names. A list split into 6 pieces. How many are senators? We got Avril Lavigne, Beyonce, and Carrie Underwood. So that's 3 out of 6. Those are senators. So I think now you're starting to see the basic fraction notation and how it works. Here's a couple quick rules for fractions, though. This might look familiar from division, because in fact fractions are division. So let's say I have 78 over 1. That's 78 first. So that's 78 over 1. Any number divided by 1 is itself. That's 78. let's say I have 2 over 1. Well, 2 divided by 1 is 2. So any number divided by 1 is itself. We got to get used to seeing fraction notation for division because we're going to be working heavily with fractions, so just know that fractions are the same as division. Well, you may be wondering about, okay, what about 1/2? You can't divide 1 by 2. Well, actually you can, but the result for that we will not see till we get to decimals, which will be after fractions. We will cover decimals after fractions, and then we will have an answer for that, but not right now. Or 3/4. Well, yeah, but you can't divide 3 by 4. Well, you can. You just get a decimal answer, which we're not covering just yet. So, all along, fractions have been division. Now, let's say I have 78 divided by 78. Well, any number that's itself, any number divided by itself except for 0, you get 1. So if I have 2 halves, 2 over 2, you're also going to get 1. You have 78 78ths, that's 1. 2 halves is 1. So the rule is any number divided by itself equals 1 unless that number is 0. That's the rule. Okay, then we'll do 0 78ths. Well, 0 divided by any number except for 0 is 0. I have 0 halves. Well, 0 divided by any number except for 0 is 0. So the rule is 0 divided by any number equals 0, where that number does not equal 0. And then, as we know, division by 0 is undefined. So any number divided by 0 is undefined. So if I have 78 divided by 0, we can't define that. That's undefined. If I have 2 divided by 0, that's undefined. So those are ways of simplifying fractions already. Next lesson we will get more into simplifying fractions, and you'll see why I taught you factoring yesterday. Merry Christmas, happy holidays, everybody. Take care.